Okay, so today we're going to start chapter 14. So last class we talked about chapter 4. We reviewed the simple linear regression from step 1. And now we're going to take that simple linear regression just to the next level in chapter 14. So in chapter 14, we're going to start with the test for significant regression. Okay. So here what we're doing, let me just write this down. We're going to check to see if the model is statistically useful. So if you remember from last class, we did check using our R squared to see, our capital R squared, to see if our model was useful. So now we're going to take it that step further and we're going to use a testing process or a CI to see if it's statistically useful, okay? So let's talk about what that means. So a model that is statistically significant. That's what I mean when I say useful. It's significant. Has a slope that is statistically different from 0. So what we're going to do is we're going to take our model and we're going to study our slope of the model. So just think about a slope that is 0 is just a horizontal line. So we want something that is useful, and that would mean that there would be some sort of direction, a positive direction, or even maybe a negative direction, okay? So not just stable here in the middle, okay? So that's what we're studying. We're studying to see if the slope has, or if the model has a slope that's statistically different from 0. So you know, we might see the number and it might be different from 0, but we want to know if it's different enough to say that it's actually different. You know what I mean? Just like we've been doing. So we're looking for something that has a slope either in the positive direction or negative direction, not just 0. So that's what we're going to study today. So we're going to talk about computing a CI for this and working through a test. And like I mentioned, the test process is real short. It's definitely a shortened test process here. So let's start with the CI first. And of course, we'll work through examples at the end. So for my CI, we're going to build a CI about beta. So this is our question: is the model useful? Of course, when I'm building a CI, the same formula as always. Point estimate plus or minus margin of error. And you know, when we're looking at this, it just depends on what my problem is, depends on what I'm plugging in here, okay? So let's recall from last class our model. So just over here off to the side, from last class, remember what our sample was. Our sample equation, our estimate equation was y hat equals b1x plus B naught, right? And B1, I'm just going to write this off to the side, then we have it. B1 is the coefficient of the predictor variable. That is my slope. The coefficient of my predictor variable is my slope, right? And S of B1 is the standard error of the slope. Find this from Minitab. Oops, move that up. Okay. So what we're looking at here is, remember, whatever we're building our CI about, which is beta, our point estimate is from our sample, right? So that is going to be B1 plus or minus T, because we're working with all numerical data, at alpha divided by 2 times the standard error, so S of B1. So this is our formula. You know we're not doing this by hand. I just like to show you what Minitab's doing behind the scenes. Okay. So as always, we want to be able to interpret the CI. Okay, so to interpret the CI, we're going to just have the same interpretation we always have. And that will be something like, we are blank percent confident, whatever our level is, that the population slope, that's what we're studying, now the context, so of the model that predicts my Y variable, given the X variable, is between our lower bound and upper bound. So it's not really anything surprising here, right? My level of confidence up there. Okay, so the only thing that looks a little different from my interpretation of my CI from before is now we're saying, instead of my, who we're studying and what we're studying, we're saying of the model that predicts the Y given the X, okay? Or you could say something like, of the model given an X predicts Y, or something like that, right? You don't have to use my same exact wording. I'm just giving you an example and something to use. Okay, so that's what we're going to do when we have a CI. But as we have to include a follow-up, right? So I'm going to just put here plus a follow-up, because fine, that's what the CI is, but we need to make sure we state what that means, right? So we might get that the beta is between two numbers, but we want to know, well, what does that mean, right? So we have to include the follow-up so we can just take it that step further and have more understanding of okay, what do those numbers actually mean for us? So we have two scenarios here. There's really three with the CI, but I'm going to break it into two. So if 0 is in the CI, so if my CI includes 0, then the model is not significant. So it's not useful. Okay, so what we're talking about, for example, the interval that starts negative and turns positive, right? So that's the one scenario. where it's not significant. Then the other scenario, that it is significant if 0 is not in the CI, then the model is significant or useful. Okay, so examples here, all negative work or all positive. Okay, so it's just like before when we're studying a CI, we're looking for 0, right? So if 0 is in the CI, then that means that my slope could be 0. That means my line could be horizontal, meaning the model is not useful. It is not significant. Okay, so that's what we're looking for. So we're always going to make our interpretation of the CI, so what our answer is, and add the little follow-up, what does it mean, right? So what does that mean to us? So that's my confidence interval for beta. Now let's take a look at the hypothesis test. I think this will fall into place knowing that we're talking about 0, right? So our hypothesis test for significant regression again, I'm just going to write what we're doing. We're testing to see if the model is useful. Okay. And let me just write here. Looking for a slope other than 0. So something different than 0. We're going to use a shortened test process. So we're going to start right off with our population. And for a population step, we just have to do one thing, and that's define beta. So here, we're going to define beta.
Professor, do you think it's possible if you could just show the bottom of that other page? Just real quick. Thank you, sorry.
It's okay. Like that?
Yeah, that's good. I got it. I just wanted to make sure I wrote everything.
Okay, yeah. So for the population, we're going to define beta. I'll define it now. And as you know, we're always going to put it in context, right? So we just say beta is the population slope of the model, or you could say of the line, that predicts y given the x. Okay. So that's what we're going to do here in our population step. We're just going to define beta. No, that looks like a B, but it's a beta. There we go. So beta is just the population slope of the model, predicts y given x. So I want that in the context of the problem always, right? I don't want you to write it like this. I want you to write it in context. I'm going to write this down because I want you to know. Everything should be written in context all of the time, right? So now we're going to jump down to our method step. And for a method step, we're just going to identify and define our null and our alternative. So think about what we're studying here. We're studying a beta that's 0, and we want to show that it's different from 0. So remember, our HA is always what we want to show, right? So our HA is going to be beta is not equal to 0, and that leaves my null that beta is equal to 0. So when beta is not equal to 0, this means it is useful. Okay. And that's what we're looking for. So of course, my sample step, we're going to include the Minitab output. as you saw from last class, there was a lot of output, right? Kind of like when we're looking at ANOVAs. So we have to learn what part of the output we're going to study here. So I'm just going to make a note of it now, but of course, when we look at an example, we'll really discuss it. So here, I want you to know we're going to look at the row, not the column, the row of the predictor variable. And this is from the coefficients section. It doesn't make a ton of sense right now because we're not looking at the output, but I'm just making a note what you're going to look at. You could put all of the output there, but what we're actually going to study is the row from the predictor variable, and it's in that little section. So you know how they're like labeled different sections, the coefficient section. That's what we're going to look at. So I think that's just helpful having that little note there so we know. So if we look back, we know what we're going to look at. All right, so for our results, as usual, we're going to report the test statistic. And we're back on the T curve. So T test stat equals whatever it is, right? And of course, we're going to mention degrees of freedom. So you can make it a different thing, or you could just put a comma, degrees of freedom, whatever you want to do. And we're going to report the p-value. Okay, so we're going to report those three parts and the results. And then in my conclusion, I'm just going to make my conclusion statement like we did before. So when I say before, I mean with the ANOVAs. You can show me. So I notice some people still show me that their p-value is less than alpha, whatever they want to show, that they can or cannot reject the null, that kind of stuff. That's all fine. But what I really want to see is your normal conclusion. So it's usually 5%. So I'm actually going to write 5% there. Level of significance. The sample does or does not provide sufficient evidence to say that the model is statistically useful, or you could say significant. Of course, if you want to write a goal up in your population step, you're welcome to do so. You know, a lot of times I like to do it, but you're not required to do it. So I'm not asking you to do it, but some people still like to fill that in. But you know what your goal is to show evidence that your model is useful, right? That's what our goal is. So that's our shortened test process. It's pretty quick, very similar to like the ANOVA, how that was really quick when we worked through it. Once you got your mini tab, you were just kind of filling it in real quick. And I think that was really nice. So I'm just going to go over the residual analysis before we work on an example together. So here, we have our requirements. I know I gave you these last class, but we're going to just talk about them again. So our requirements, this is called residual analysis. Okay, those are our requirements. So like we talked about before, we have 4 requirements. So the first one is that the residuals must be independent. And like I mentioned before, we want to see no pattern, Okay, so we don't want to see a pattern. In the residuals, remember what the residuals are, that's just my error, right? Versus fitted Y plot. Okay, so that's what we're looking at. Our second requirement, that the residuals must be constant, have constant variability. And what I'm talking about here is the spread. So again, we're going to look at the residuals versus fitted plot. So it's the same graph, and we don't want to see a sideways V, okay? So we want them pretty spread out. So I'm just going to put no sideways V. So what we don't want to see is we don't want to see something like this or like this in the plot. So what I mean is I don't want to see the dots on the left all really close to my center line. So it would be like, this is what I mean. Okay. So if this is my center line, I don't want all the dots really close and then start spreading out further and further as I go right, or vice versa. All spread out on the left and then get closer and closer to the center line on the right. That's what I'm talking about. I do not want to see this. And this is, again, on the residuals versus fitted plot, which Minitab will give us this to us. I just have to ask for it. So we're going to go over that, how to ask for that today. Okay. And then the third one, no outliers. So here, I'm looking for the values to be, so my dots, I'm going to say, within 3. So I'm going to put plus or minus 3 here. So when we look at this, I'm going to put on residuals versus fitted plot. So when I'm looking at that plot, I can use that same plot for the first 3 requirements. So up here, I just want them to be all over the place, okay? No pattern. So no line, no curve. I don't want any pattern here. And then on the second one, I don't want to see a sideways V, right? I want it just to be pretty equal where all my dots are located. And then on the third one, I don't want to have any outliers. So I don't want any dots outside of positive or negative 3, okay? It's a pretty quick check for all of these 3. I know it seems like a lot, but it's a pretty quick check. And then the fourth one is we're looking to see if they follow a normal model. So residuals follow a normal model. So what we're going to do here is we're going to do our normality test as usual. So I'm going to look at the NPP of the residuals, my errors, okay, and the normality test. And you know the normality test, I'm looking for a p-value greater than 0.05, right? And those are my 4 requirements. I need them all to work out. So if one does not work out, then I'm looking at my model not being valid, okay? So for my requirements, let me just write this. So we're wondering, is the linear model valid? So what I'm saying here is I want to know, is a linear model the way to go? That's what we're checking. So if something doesn't check out here, then I'm going to say, well, my linear model is not valid. So all 4 must check to say yes. Okay, so all you need is one of these to fail for you to say a linear model is not valid. It's not just saying that a model is not valid, it's saying a linear model, since that's what we're studying, a linear model. Okay, those are my requirements. That's what we call residual analysis. So remember from last class, when we're building our model and we're getting our equation of our best fit line, our least squares regression line, that's called regression analysis, right? Where here, the requirements is called residual analysis. I just want you to be familiar with that wording. So if I ask you for that, like I might use that wording. I might say perform residual analysis. And this is what I mean, all of this, okay? Okay, so I want to take a look at some of the notes. So I want to just show you some of this stuff from this residual analysis a little bit, and then we'll look at an example and we'll go through that residual analysis with our example. So I'm just going to share my screen here, and we'll take a look at the day 22 notes, and we can see. I am not in the right part here. Sorry, I feel like this happens all the time because I'm like looking at them before class and just making sure I have everything in them. Okay, here it is in the notes starting on, it's really like page 5. Sorry if that's making you guys dizzy. So this right here, this little graph right here, this is like the kind of plot we're going to look at, the residuals versus the fitted. So let's just look at the different ones. So here are all my requirements right here. This is just some directions how to do it. I'm going to show you that in a few minutes. So I know I mentioned this last class, but see this plot right here, how all the dots are all over the place, right? That means that they're independent. There's no pattern. I don't see a straight line. I don't see like a parabola. I don't see any sort of pattern. So I'm going to say that these are independent, okay? I'm looking at the dots. Now, when I'm looking at this, I now want to look for constant variance, constant spread. So what I want to look for is if there's a sideways V. So I want to make sure there's no sideways V here. So if the sideways V would mean that all these dots are closer on the left to my 0 line and then more spread out as I move to the right, or vice versa, where they're more spread out on the right and closer to the 0 line on the other side. Oops, did not mean to move that. Let me show you down here what I mean. Okay, so right here, this is what I would consider constant variance. Do you see it? They're all over the place. They're not closer to the 0 line, the horizontal line on one side versus the other. Right here, these two are showing sideways V's. So on the one on the left, you could see where it's closer. All the dots are closer to 0 on the left, and then they're more spread out on the right. That's a sideways V. That's where I'm saying they don't have a constant spread, right? These are closer together, and then these are more spread out. Where these start more spread out on this graph, and then they end closer together. So we don't want that. That's a sideways V. So that's something we don't want. And then for the outliers, I don't know if I have a graph to show it. I don't. But we just want the outliers within positive and -3. You'll see the scale on the left and right, positive and -3. If you have a dot outside of that, then you're going to say it's not, you have outliers. We don't want that. And then, of course, the normality test, I don't think I have to go over that because that's a pretty normal thing. We've done a lot this semester. Okay, so that's my residual analysis. So now what I want to do is I actually want to look at an example with you guys so we can work through this. Whoops, I did not mean to do that. Okay, so let's take a look at, we'll go back to the notes. Sorry, I didn't have to get out of them. Let's see, page 12, example 1. Now, this is the same example we looked at last class, the baby weight versus the mother's age for adolescent mothers. And I think it's a good example to continue with because we're already familiar with some of the information we got from last class, right? We're familiar with that problem. Okay, so remember from last class, we were studying adolescent females and the birth weight of their babies. So we're talking about teenage mothers and the birth weight of the babies that it's in grams, okay? So don't get overwhelmed by these large numbers. All right. So here in this problem, it says perform regression analysis. What I mean is I want you to fit the model. So I want you to actually build the model and get the equation. And then in part B, I ask for specific parts because I want you to get familiar with this output. And I want you to actually just search around the output and find some of these values. So A and B, so I'm talking about the slope and the y-intercept of the equation. The sum of the squares of the error, the mean of the sum of the squares of the error, so it's just the average of those, and just where you're finding all this information. Your standard error, remember that's S, okay? Degrees of freedom in the problem, that kind of thing we're going to look at, which I don't think I told you what degrees of freedom is. I don't think I told you, but it's n minus 2 in this problem. So sorry about that. Not just this problem, but for simple linear regression, it's n minus 2. And I apologize. I don't think I wrote that down. Then in 1C, it says test for significant regression. So that's my testing process. You're going to show that full testing process. It's shortened. You're going to show that. And then we're going to build and interpret a 95% confidence interval. Remember, sometimes the results are so close that a confidence interval might actually give you a different answer than the testing process. That happens once in a while. So don't think you did something wrong. It's just maybe your results, it's like on the line, it's like borderline, you know? And that's what. So on page 13, we have the completed example, but I want to go ahead and open up that mini tab and we'll work through this. We're going to build our model. We're going to identify some of these values, and then we'll work through the test process in the CI. So I'm going to share my mini tab screen. So if you go into day 22 notes, you will see baby weight mini tab file there. So it's the same one as last class. So if you want to open that, feel free, or you could just watch and follow along that way. Okay, so the first thing I'm going to do with this one is I'm going to build my model and fit my model. So I'll start at stat, then regression, and regression again. Then I'm going to fit my regression model. I'm going to click here. I just need to tell Minitab which one is my response and which one's my predictor. Remember, it's X predicts Y. Y is the response, the predictor is X, right? So last class we discussed that mother's age can predict the baby's weight, and that's what we're studying. If you ever have a question on which one's which, let me know, but always just keep in mind X predicts Y, and that normally straightens it out for you. Now, last class, we didn't actually ask for anything extra here, but that's because we weren't working through the residual analysis. You don't have to do it when you make and build your model right away. You can go back in. But as you know from before, if I can, I will try to get everything I need the first time I build my model, then I don't have to go back in. Going back in only is going to take you like another 30 seconds, so it's not a big deal, but I'm going to try to do it now if I can. So the first thing I want is I want to get my fits versus the residuals versus fit graph so I can do my residual analysis, my requirement check. So for that, I'm going to go under graphs here. So within building my model. So I'm going to click on that, graphs. And up here at the top, the second part says residuals for plots. I don't want regular residuals. I actually want to look at standardized residuals. This is going to help me when I look at my outliers. So I definitely want to look at standardized, because if you just look at regular, your numbers go up to like 50 or something large, and you don't know what is considered an outlier. This way, you know standardized, anything outside of positive or -3. It's going to be an outlier. Then I need to tell Minitab which graph I want. I want residuals versus fits. So it's the second from last right here. I don't have to click on anything else or do anything else in this section. So I'm just going to click OK. So what this is going to do is with my output of all my numbers and all my tables, I will also get this graph, which that will take care of my first 3 requirements. So that's really good. Now, if you remember your 4th requirement, we have to look at an NPP using my residuals. So in order to do that, I need to get the residuals. So I need to ask Minitab to make a new column with my residuals. So I'm going to go over to storage, in the bottom right here, click on storage. And just like we did before, I'm going to ask for the residuals. So you can use residuals or standardized residuals. I typically just stick with standardized residuals. It doesn't matter, you'll get the same results. The reason why I typically stick with standardized residuals, because that's what I got in my plot that I just asked for, that we haven't seen yet. So I normally just stick with that, but either one of these will work, okay? Residuals or standardized. So I'm going to click OK. I'm going to click OK again. So now if you remember from before, if you were a Mac user, your standardized residuals didn't show up in column 3 like they do for me. They showed up in like column like 297 or something. So keep that in mind. You ask for them, they're going to be there when you want to build your NPP. You might just not be able to see them. Okay, so here we built our model. So remember this top piece of output, this is my regression equation. So this is what I'm looking for when I say perform regression analysis. This is what I'm looking for. If you want to include all of your output, that is completely fine because we're going to use more of it, right? We're not going to just use this top piece, okay? So now in my question, it wanted to know what is A and what is B. So given that the equation is y hat equals A plus BX. So B is the slope and A is the y-intercept. So clearly we could see B is negative 1,163 and A is 245.1, my slope, okay? And from last class, we know how to interpret those values, right? Now it wants to know what is SSE. So I'm going to show you where to find SSE. I'm going to look down my analysis of variance. So remember we had this with ANOVAs before, like in unit 2. SSE, so right here, SS, and E stands for error, right? So right here, I've got 337,000 number. And then MSE is just the mean of that. So it's SSE divided by the degrees of freedom. So right here, it's the average. So it's that 42,000 number here. Then I want my standard error. Remember we found this last class, it's 205.308. That's S here in Minitab, but we call it SE, right? My degrees of freedom is this right here. It's 8, okay? And like I said, it was N minus 2. So, but it's given to you. So you don't have to calculate it on your own. It's right here with the error, 8. Okay. So now let's go ahead and go back to our notes. I'm going to bring my Minitab over and we'll look at the test write-up. So if I go back to my notes on the following page, it wants me to do a test write-up. So here's all the output. I kind of have stuff highlighted where I found all the information. So I think that's really useful for you guys. All right, so my test write-up. So beta is the population slope of the model that predicts birth weight given mother's age. So it's like a really quick write-up. My null is beta is equal to 0. HA beta is not equal to 0. So my T and my degrees of freedom and my P, I need to show you where to find those, right? So remember what I wrote in our notes. When you have your output, it's the coefficients piece right here. Coefficients, and you're going to look under the predictor. So the predictor is mother's age. That's my X. My T value, I have them highlighted in green, 5.34. My P value, so that's the area in the tails, 0.001. Okay. My degrees of freedom we just talked about up here is 8. So you notice right here I have a note. Degrees of freedom is N minus 1 minus K. So K is the number of predictors. Here it's just 1, right? Because we have 1x. It's simple linear regression. So for simple linear regression, my degrees of freedom is always n minus 2. Okay. And then I'm going to say at the 5% level of significance, the sample does provide evidence to say that the model that predicts birth weight given mother's age is useful. Okay, because I am rejecting my null. All right, let's take a look at the confidence interval, and I forgot to get this. So I do have to go back and build my model again because I totally forgot to get my confidence interval. I was excited that I remembered everything, but I did not. So I'm going to go back to Minitab. I need to go back into my model because I forgot to ask for my CI. So back to stat, regression again, fit the model. So I need to ask for my, my CI output. So here I need to go back to results here. So I should have remembered, you click on graph, results, and storage. I totally forgot. It's the results tab. So here for my results, I need to ask for my CI. So see at the top, it says simple tables. I'm actually going to expand that to expanded tables. So it's the very bottom option here, expanded tables. I'm going to click on that. Okay. So now from here, I can go ahead and click on OK. And if I need to, I can change my CI level. Okay. So from here, click on OK. I could go to options. I know this is like a lot. It's all typed up in the type notes. If I click on options here, right here, my confidence level, 95. So if I need anything other than 95, which typically you won't really need to change it, but you can, you can change it here under options. My confidence interval, you never change that. It's always two-sided, right? We never change that. It's always the not equals. So now I can click OK. And we can see here where I have my confidence intervals. So it expanded the tables, right? And it gave me the CI. Okay, so let's go back to our type notes. So sorry about that. Sorry about forgetting to get that. But as you see, it doesn't take very long to get it again. So right here's my CI results. I highlighted it here for you. So it was easy for you guys to find. So again, I'm looking in the coefficients output section. Again, at the predictor variable. So the mother's age, and here is my CI. So I can say that we're 95% confident that the slope for the model that predicts baby weight, excuse me, given mother's age is between 139.3 and 351.0, right? Then I have to make my follow-up. It's a positive to positive. That means 0 is not in my CI. If 0 is not in my CI, that means I have a significant slope. So meaning I'm showing that my slope is something different than 0. That means that my model is significant, it's useful. And that's what I'm going to state. So since 0 is not in the CI, we have evidence that this model is useful. Okay, so that's my CI. Any questions on that part so far? So I did the full test and I did the CI. They're both showing that the model is useful. Let's go back to Minitab then, and we will take a look at our plots, okay? So this is my residual analysis part. I didn't ask for this in the example. I just wanted to go over this with you guys. Because I am going to ask you in the daily today to do this. So here's my residual analysis. Remember for that I don't want a pattern, right? I want them to be independent. So that means I just want the dots all over the place. This one doesn't have a ton of dots, which it shouldn't, right? Because my n is 10. So here I'm looking at, I don't really see a pattern. I mean, you could say it starts low and kind of goes up high and goes back low. I don't know. I would say for this one, I do not see a pattern, okay? This is just a visual for you guys. The other one is a sideways V. So are the dots close here and then they go further away here, or vice versa? Do they start further away on the left and then get closer on the right? I don't really see anything like that. They look like they're all pretty much all over. I know this one up here is further away than some of the others, but it doesn't mean that I have a sideways V. Okay. Sometimes it's a little tricky and it's just what you see. So it's kind of more of like an opinion based thing, right? So I'm going to say, I don't see a sideways V. I believe that I do have constant variability. Then for the third one, I don't want any outliers. This is why we do the standardized residuals. Look at over here, my numbers, my scale. It goes from negative 1.5 up to positive 2. I'm looking to be within 3. So there's definitely no outliers because my scale doesn't even go to 3. There's no outliers on this one. Then the last one is that I want my standardized residuals to follow a normal model. So here I'm going to look at graph, probability plot, as we usually would. And I'm going to look at the single plot of my standardized residuals. Now, it doesn't matter which one I choose because I did the model twice, so they're the same numbers. I'm just going to go with the original, click OK. So here's my NPP. It does look fairly linear, but remember what I'm doing is I'm looking at my p-value. It's 0.7. So the p-value greater than 0.05, I can go ahead and say that my residuals are following a normal model. Done. Now I want to make a final conclusion and say that I've met all 4 of my requirements. So this linear model is a valid model. Okay. And that's what I'm doing for my requirements. That's my residual analysis. It goes so much quicker than it looked on paper because on paper there's like a lot of information to give, but when you're actually looking at it, it's just visuals, most of them, right? So there's not really a lot to write up. All right, do you guys have any questions for me on this?